careful what I'm saying. Recording is about to start, and let's hope that the screen sharing works. Start broadcast. Okay, and hopefully you should be able to see my screen. I've heard worse things than the blood type and pregnancy tests and things like that. So, and I will say something about. Yes, thank you very much, Bernardo. That was the cue. Thank you. Please don't forget to register attendance. And I've been asked about what will happen with coming back on the 8th. What will the exam format be? I will say something about that when the session starts. So bear with me. We will get to it. And you are in for a massive surprise. I can tell you that. Oh, are you breeding some mold colonies? Would be interesting to see what kind it is. But mold does not necessarily mean that it's a bad thing. Oh, that's fine. That's not a problem with the potatoes. You just mash them if they are not mash. Well, it depends. If it's black, then usually it's Aspergillus niger. And that is something I would be careful with. You then, therefore, will report that to housekeeping. And no, I would not eat it because that A, it doesn't taste nice, and B, it can be actually quite dangerous. Oh, that sounds good. Okay, shall we make a start? Excellent. So very good afternoon, everybody. And thank you for tuning in to the for the BI308 Skills for Bioscientists, where we will continue today a little bit with what we have done in the past few weeks. But as I said at the beginning, just a bit of information, or rather not information, about what is going to happen on the 8th. Actually, to be perfectly honest, I have as much of an idea as you guys have what happens with practical classes, with teaching. My feeling is that at the moment, the university is trying to figure out what we are going to do, especially in biosciences, because we do have practicals. If I was a gambling man, I would say I would not necessarily put a lot of money on you lot actually being asked to return to university. If you are already at university, okay, then you are at university, but I'm not entirely sure if practical classes will take place in person. I do not know. Teaching is very unlikely to be going back to the normal full class. But I might be wrong, so please don't quote me on it. But as I said, I'm not entirely sure what happens with practicals and things like that. But you will be informed as soon as the university has reached a decision. People have asked me what format will the exam be for you lot. Now, the answer is, again, I do not know exact the format. Last year, no, in previous years, so 2016, 17, 18, 19, the exam format was that in those modules where you do an exam, it is split in two sections. Section A is 30 multiple choice questions. Section B is a problem-solving question or an essay question.
Oh, Kitty, but shouldn't be sleeping, should she?
Genau. Yeah, that's exactly what I say. So it's these two sections.
Okay.
And last year, however, we ditched the problem solving. So you only did 30 multiple choice questions in the exam. How it is going to be this year, again, your guess is as good as mine. Are we going to revert to the multiple choice plus problem solving stroke essay question? Or do we keep just the multiple choice question? I do not know. I have no idea what the format will be. And how do you know? I would assume you just have to learn everything. I know it's a pain, but if you've worked all right so far with me on the BI308 and the BI301, at least you will be absolutely fine in these two modules. Okay, so now let's do a quick recap of what we have done previously. And I think I gave you the example of the butterflies. And that was in week 16, I think. In week 16, we discussed this goodness of fit, the goodness of fit test. Of fit test, also known as a chi-square test. a special form of the chi-square test. And if I remember correctly, we looked at the genotypes of some butterflies, and we found that we had lowercase a, we had 35. For the heterozygotes, we had 55. And for the homozygote, capital A, we had 10. And that makes up 100 butterflies. Is my board up? Okay, good. So probably not my end. I can see that it is broadcasting, so hopefully it does work. If not, just rejoin, I would say. And in this goodness of fit test, this chi-square test, we are looking at some kind of, we compare our data with predicted data, and we said our predicted data, predicted, if it follows the typical Hardy-Weinberg, or let me say that instead of predicted, let me call this expected data. Expected. We said if it is Hardy-Weinberg, we would expect 25, 50, and 25. And that again gives us a total of 100. And what we can do now is we can calculate a chi-square value, which is abbreviated like that. And I showed you how we can do this chi-square value. This just simply follows the equation of observed numbers minus the expected number. We square that and divide it by the expected number. And we do that for each one of these genotypes, add them all up, and we then get a value for this chi-square. And we've done that in the last session, and I can't actually remember exactly what this was. What was it? I think it was 13.5. So that's the chi-square value that I showed you how you can calculate that. And then people said to me, yeah, but what does this actually mean, this 13.5? And what is the point of calculating it? What does it tell us? And what the point of calculating this chi-square value is, actually, we will see in the following sessions. Not today, in the following session. Just trust me, there is a system to the madness. And I tell you what this calculation, this chi-square value that we just calculated here, what this actually means. I tried to show you how you can do that in Excel, but I realized that it did not work very well. So I thought, okay, let's try to do a different method. What we are actually looking for here now, in principle, if we just take a step back, what we are looking for here is we ask the question, our null hypothesis asks the question, are the, or let me write this differently, let me write it again differently. There is there is no difference. There's no difference between observed and expected data all differences can be explained by sampling error only. So that is our null hypothesis, right? And it's always the same thing. There is no difference between the observed and the expected data, and all the differences that we actually see can be explained by the sampling error. The alternative hypothesis is there is a difference. There is a difference between the observed and expected data, and the differences are due to sampling error. The sampling error is always there. Are due to sampling error and additional factors. So before we do anything with our data, we set up these two hypotheses, H0 and H1, the null hypothesis and the alternative hypothesis. And before we then move on, we define a sort of cutoff point, where we say if the probability for something is lower than this cutoff point, then we think there's something weird going on. This cutoff point is also called the significance level. Significance level, usually abbreviated with alpha, and very often this is set to 5%. This means if we have a probability that we see this observed minus the expected, if we have a probability larger than alpha, we accept H0, the null hypothesis. Then we say there is no difference between the observed and expected data. If P is smaller than alpha, then we say we reject H0. Okay? You know what 5% is? %5 is 0.05. What if P equals alpha? You have a problem. 13.5, that's a very, very good question. It is really good. No, it's not a percentage at the moment, but I will show you next time how we can convert that into a percentage. So how do we actually now find how do we find P? Right? How do we find P? And I tried to show you to do that with Excel, but it doesn't show very nicely. I might put a little tutorial up there to show you how you can do that in Excel. But as you know, I quite like the idea of online calculators. So let's try to find a good online calculator where we can do this calculation. Okay, so I head over to my browser and I put in chi-square goodness of fit calculator. So you see that here, goodness of fit calculator. And it comes up, and I really like the first one where it says socialstatistics.com, chi-square calculator for goodness of fit. That's the one that I recommend. And I will put up a link to that. So let's see what we can do. So here it asks us, what are our categories? So we can put here our categories. We had AA, we had the heterozygotes, and we had the homozygote capital A's. The significance level is very often 5%, but it doesn't have to be. You can set it at a different level, but very often, I would say in 95%, 95% is the 5% is the significance level. Brilliant, thank you very much. So here we've got our categories. Now we need to add the observed numbers and the expected numbers. So for the observed numbers, we had 35. And for the expected, we said it was 25. For the heterozygotes, we had 55 and we expected 50. And for the homozygote capital AA, we had 10 and we still expected 25. Okay, so here it asks us for the significance level 0.05. And all we need to do is we can calculate chi-square. It looks good. So the chi-square value it shows here is 13.5, as you see here. And it calculates a p-value. It calculates a probability. It calculates the probability that we get this chi-square value if there's no difference between the observed and the expected data. So let's write this down, 0.00117. So calculator, that's the online calculator that answers the question, how we find it, and we get P equals 0.00117. That means the probability to get the observed values, to get the observed data, if the null hypothesis is true, is small, is very small. It is actually smaller than 0.05, that's our 5%. And therefore, we say H0 must go. We reject the null hypothesis. Yes? So we reject the null hypothesis. Absolutely right. Did you get it, how I did the whole thing? I did my null hypothesis. I did my H1. I set the cutoff point. Then I calculated the p-value with the help of this online calculator. And now I can say, yep, there is a difference between the observed and the expected data, which I cannot just simply explain by the sampling error. There must be additional factors. Can you work it out? Actually, the answer is no. Not with our mathematical methods. So you need to use an online calculator or a graph or Excel. Excel can do that as well. Or you use tables, but I don't like tables. Only when you can eat from them. Yeah, you had these tables, which are a total pain. And usually people within 5 minutes forget how to use these tables. I mean, why? Do you go to get your food and hunt it with a spear? What's the point? This is old fashioned. This is just, forget it. And people tell me, yeah, but what are you going to do if you are in the middle of the rainforest in the Amazonas and you have no internet connection? Well, the chance is that you have statistical tables with you is pretty remote. And if you are in that situation, probably calculating a p-value is the least of your worries. Right? So I have no problems if you actually use an online calculator. So this was the goodness of fit test. But we can expand this to another type of chi-square test. And it has different names, but they mean the same thing. It is test for independence, test for independence, or test for association, or test for linkage. Yeah, exactly. Now, let's go back to our butterflies. And let's say we notice that there seems to be something weird going on, because we find that we have different colors. We have red and blue butterflies. And these colors appear to depend on the sex of the butterflies. So we find that 35 butterflies are female and red, whereas 15 are female and blue. With the males, we find it 15 and 35. Let's do it like that. So what we have here is a table. This table consists actually of 2 rows and 2 columns. Beautiful, yes. So we have got 2 rows 2 rows, 2 columns. And we only count the ones with data in it. So this is also called a 2 by 2 contingency. Oops, let me write this properly. Otherwise I get complaints. Contingency table. A 2 by 2 contingency table. Okay. Now what we can do is we can calculate the marginal values. Marginal values is just simply by adding up the rows and the columns. So marginal value, we have, how many females have we got? How many females have we got? Just to keep you entertained. Yep, that's right. 50, and males we also have 50. How many red butterflies do we have? Also 50, yep, and 50. And how many butterflies have we got in total? 100. Actually, how is the gender defined in butterflies? In mammals, obviously we have males and females, and the males have X and Y, and females in mammals have double X. What it is? How does it work in butterflies? Does anyone know? It's also with sex chromosomes, I can tell you. And don't Google it. No? They have a very similar system, only they are not called X and Y. They are actually called W and Z. And in butterflies, the male are actually homozygotes for the sex chromosome. They have 2 W chromosomes, whereas the females have 1 W and 1 Z chromosome. So it's exactly the other way around as it is in mammals. Just as out of interest, I thought I put that in. Okay, so we have 50 females, 50 males, and 50 red and 50 blue. And now we can set up already our null hypothesis, H null. And again, what we can do is actually, I'm a bit naughty. I copy that. That's our null hypothesis that we did before. Because the null hypothesis is exactly the same thing. There is no difference between observed and expected data, and all the differences can be explained just simply by sampling error. And H1, there is a difference. The differences are due to sampling error and an additional factor. So what we are looking at now is we have our observed data. These are the observed data. What are the expected data? That's now tricky, isn't it? What are the expected data? I show you in a minute how we can actually find expected data if we really need to. But let's set our significance level. So let's set alpha. And we set that as per usual to 5%, the cutoff point. So we've got everything together. We've got the cutoff point, significance level, and we want to know how we can calculate the probability if our observed data are matching the expected data. But we still haven't got the expected data, and I haven't showed you how we can calculate the expected data. I leave that to the end because you will find we actually don't need to do it by hand because guess what? What are we going to use? Let's see. We are going to do an online calculator. Absolutely right. We are using an online calculator to calculate the p-value that we actually get these observed data. Let's go to a browser and let's see if we find an online calculator. Chi-square 2 by 2. Oh, look, there is one here. Oh, again, it's under the social statistics thingy that Bernardo also posted the link. But this time it is this 2 by 2 contingency matrix. And it asks us about our different categories. So we can set this up and we can say ladies first, female. Category 2, we have male. Group 1, that was, what was that? That was red color. And group 2, that was blue color. Okay, so that is set up for it. Next, what we need to do is it asks us to put in the data. So we said we observed 35 red female and 15 blue female. And for the males, we found 15 males and 35 males. Excellent, thank you very much. So we've got our data in there. Just click next. And we want 0.05, that's the significance level. And let's calculate, and look, it comes even up with the marginals that we have calculated. Now we can calculate the chi-square value for that. Well, actually, we are not terribly interested in this case. The chi-square statistics is 16. I tell you in a minute how we get this, but we find that the p-value is 0.000063. So that's 4 zeros. Let me write this down. P-value from online calculator. P-value from online calculator 0.000063. Nicely spotted, Daria, nicely spotted. I'll come back to that in a minute. So this p-value is very, very small. It certainly is smaller than 0.05, and therefore, do we reject or accept the null hypothesis? Well done, yes. Therefore, reject the null hypothesis. So there is a difference between the observed and expected data. But what does that mean? In the case of link analysis or test for association or independence, depending on how you want to see it, we say the null hypothesis is valid if there is no association, if there's no association between the two categories. Between the two categories. So there's no association, no association in our case between gender and color. That is basically that is basically what the null hypothesis in this case implies. The alternative hypothesis is there is an association. Between the two categories. That is basically how we can reword the null hypothesis. And as we said, we have a p-value that is very, very low, and therefore we can reject the null hypothesis. So in our case, we reject the null hypothesis, and we can say there is an association between the two categories. Oops. Are we still in business? Can you still see the screen? Okay, good. So from our experiment, we can say color and gender of the butterflies are somehow linked to each other. Because we accepted H1, there is an association between the two categories, between color and gender. We now can say there must be a link between color and gender. It could very well be that the gene for color is on one of the sex chromosomes. So that is what we actually got with this chi-square test for association. Now, I told you that we are dealing with expected numbers, but how can we actually calculate the expected numbers? Let me do the 2 by 2 contingency table again. like that. We had 35, 15, 15, 35, 50, 50, 50, 50, and 100. That's observed. And now we calculate an expected table. And that table looks pretty much the same. Red and blue. But now we are trying to figure out the numbers that we would expect. The margins stay the same, right? The margins stay the same, but for the expected, we say, well, half of our butterflies are female. So half of them are female, and half of them, half of the color is red. So half of them are female and half of the color should be red. How many red and females should we actually have? What do you think? Half of them are female, half of the color should be red. 25, you're absolutely right. 25, because half of them, half of the females should be red and half of the females should be blue. So it would be 25 and 25. Absolutely right. And also, what about the males? Is it also 25 and 25? It's also 25 and 25. Absolutely right. So these are our expected numbers. How do we get to these numbers if we don't have these nice 50-50? Well, there is a little trick if you have to do it by hand. I remove that. What you do is you take this number here and you take this number here. You multiply them, 50 times 50 divided by this number here. Did you see that? 50 times 50 divided by 100, that gives me 25. Did you get it? What about this number here? 50 times 50 divided by 100. Right? Again, gives us 25. And you can do that for all of these fields. Let me remove that. So we have 25, 25, 25, and 25. And what we can do now is we can do our chi-square test. Chi-square equals observed minus expected squared divided by expected. And we sum them all up. Oh, that's a terrible sum, but you get it. So let's do it for the first field. We have 35 observed, expected 25. So we've got 35 minus 25 squared divided by 25. Plus, we do that here. 15 minus 25 squared divided by 25. Plus, now let's do this one here. 15 minus 25 squared divided by 25. Plus, and let's do the last one, 35 minus 25 squared divided by 25. 35 minus 25, that's 10, squared is 100, divided by 25, that's 4. Plus, that's 10 squared, 100 divided by 25, is 4 as well. Plus, we just did that, 4 plus, that's, we did that at the beginning, that's 4. So our chi-square value is 16. Right, that's the chi-square value. Double check. Did I get that? Yes, we've got 16 here for the chi-square value. And what we do with the chi-square value, like with this value, I show you then next week. But Daria asked, why are there two p-values? And you can see they are different from each other. Well, here it says, you'll notice we've also calculated chi-square statistics with the popular Yates correction. There is another correction like we had with the binomial, and sometimes people use this Yates correction. It is, I would probably say, hands off. Don't use this Yates correction because it just simply complicates things. So don't worry about the second one. And it says here, there is probably a consensus now that the correction is overcautious in its desire to avoid some errors, but it's there if you want to use it. My advice would be just simply don't use it, ignore it, don't go for Yates, but you have seen it exists, and therefore, yeah, let's not worry. So in this session today, I showed you how we can expand the chi-squared from a goodness of fit to basically a two-dimensional thing where we have this 2x2 table where we can test for linkage. Is there an association between two categories? For example, is there an association between lung cancer and smoking? These are questions that you can actually test. Is there an association between gender and intelligence? And we all know that, excuse me, are more intelligent than the other gender, right? So with this test, with this chi-square test, for which there is an online calculator, you can figure out whether there are two categories, two data sets, two categorical data sets, two categories, let's call it, are actually linked to each other somehow or not. And if they are linked, then it's your job to figure out as a scientist, what is the link here? Right? Does that make sense? Now, I've promised you, I will tell you why we calculate this chi-square value. But in order to understand that, I want you to do some homework. I will post in the Moodle forum yes, homework. It is just a 15-minute video which will talk about PMF, PDF, and CDFs. And we need that for the rest of the statistics course so that we understand why we calculate certain values. PMF in this case does not stand for proton motive force. PDF does not stand for portable document format. And CDF is not something filthy that you do with your partner. Right? And I know that half of you are now heading over to Urban Slang Dictionary to find out what CDF might stand for. And I just made that up, that it might be something filthy. So I would be surprised if you find something. So homework for next time, I will send you the link to a video. Check out what PMF, PDF, and CDF actually mean, because we will need these terms in the next session, which is next week. I know it's during enhancement week, but we had last week the question answer session, and it is an officially timetabled session next week. If you don't have any further questions, thank you very much for watching, and I shall see you whenever I see you. BI301 people tomorrow. Have a lovely afternoon. And yes, that's the one. And be good. Don't do anything I wouldn't do. Take care. Bye-bye.